Very good morning, everybody. I hope you can hear me loud and clear. And welcome to our presentation today, which is called Hack-Proof Your Code, Exploring Mobile App Weaknesses with the OWASP MAS. So I'm not alone today. As you can see on the top right corner, there's also Carlos. We are both the project leads for the MAS project. Carlos cannot be here today. He's based in Berlin. But basically, we are taking care of the project with a lot of other people in the last few years. We are involved in a project since, I think, 7 years now, since 2017, and are leading the MAS project, the Mobile Application Security project. If you have any questions, also after the talk, of course, feel free to reach out to us. You can see here some possibilities to contact us. There are way more than that. You will see that at the end of the slide. But I would say let's dive directly in. So who here knows CWEs or have heard about that? Okay, so a few. So CWEs are common, Carlos also great. So common weakness enumeration is CWEs. So for those of you that do not know it, it's basically something that describes weaknesses in software. And it's something that is being done by MITRE from a nonprofit organization that is also responsible for MITRE ATT&CK, for CVEs, and a lot of other things. So what we were trying to do is to adopt this approach and to map this to the project, to the MAS project. So we call it now MASWEs. And what this actually means, I will show you in a bit. But just that we're all on the same page for those that have maybe not heard yet about the project or do not know all of our deliverables. So the project is basically divided into a few different parts. So one is the OWASP MASWS, which is the standard. So the standard has different kind of controls, control groups, we call them. You can see them here on the left side. So this is our website where everything is located and accessible under mas.owasp.org. And you can see here on the left side, there are 8 in total different control groups, and there are different kind of controls. All of these controls, they're very broad and formulated in very short, precise sentences, and they're applicable to iOS and also to Android. On the other side, we have the MASTG. The MASTG is a very big book. I mean, I have a copy here with me. So if you still know phone books, that's basically the size of it. That's what the contribution was of the last 7-8 years from a lot of people around the world, and that have contributed to the project, the brain dumps, and were sharing their knowledge publicly as part of the project. So in this, the MASTG, you will have a lot of tests, how you can execute and verify all of these controls that we summarized and articulated in the MASWS. And now we have a third thing, a third deliverable, you could say, which is the MASWE. So this one, you could say, is an interface. You can see here on the left side, the MASWS, on the right side, the MASTG with all the tests. And the MASWE is introducing weaknesses. And these weaknesses, I will share with you now in a little bit more detail what this actually means. Carlos will be giving you later an overview about different kind of demos. This is another really exciting topic that we have in the project, but more to that later. So MASWEs, as I was saying, is supposed to be the interface between the standard and also all the different kind of test cases that we're having. There's a blog post also around this that is showing you a little bit more the intention of this. So you can definitely have a read about that. That gives you a little bit further information. But I will dive now directly into an example. So on the left side, you can see one of the controls from the MASWS. And it says, the app employs current strong cryptography and uses it according to industry best practices. Okay, that's great. But what does this actually mean now if you really want to verify this and test this also? So this is where the weaknesses come now into the picture. So you have a control that is very broad, and then you have one or more weaknesses to this control. And in this scenario, one potential weakness might be cryptographically weak pseudo-random number generator. So now it narrows down already a little bit further. So now it's talking about PRNGs. But what does this mean again? So how can I test can I verify this? And this is where the test cases come in that we are working on, or the community is working on how to verify all of these different weaknesses. So every weakness might have one or more tests, so we can more specifically say how we can test all of this. And one example is test one, insecure random API usage, because the Java APIs, for example, in the context of Android, they offer different kind of random API usage. There's the random function, there's secure random, and then you can test for this. Or you have non-random sources that are being used. For example, some people might just be using a Unix timestamp or a date format, something that might be random, but is not really truly random in the context of cryptography. So how this looks like if we go now to the that we have a list that so let me get back to the far at the moment also created. So we, okay, nice. Okay, give me a second. Let me quickly, Carlos, can you hear us again? Somehow Zoom was just restarting.
Yeah, I'm here.
Okay, cool. Let me do this again. Sorry for that. That was a surprise to me. Okay, and we're back. So what you can see here on the left side are all the different kind of weaknesses that we have so far. So they have a structure, it's a table structure that you can see here on the left side. They are unique IDs, so they're all identifiable. They have very precise and short titles. Then you can see here what kind of platform they are being applied to. Usually the weaknesses should be very generic. So this means a weakness should be applicable to iOS and then also to Android. Having said that, there might, of course, be edge cases where a weakness is only applicable to one platform, meaning only Android or only iOS. Then we have a reference to the MASWE IDs, meaning to which control is this weakness now referring to. And we have the profiles. Profiles is something that we already have for a very long time, or back then we just had different kind of levels, level 1, level 2, and resilience. Now we call them profiles. And what it means is that if you have an app that, for example, has not really much sensitive data, you could consider this as a so-called level 1. And then only a subset of these controls and also weaknesses might be applicable to you. If your mobile app is, for example, processing payment information, you have financial transactions, then you might want to consider level 2 controls because you obviously have more risk to it. And there are more profiles like for resiliency, root detection, and all these kind of resiliency controls to slow down reverse engineers. And we have a new one that is also called privacy. So we're expecting that this is growing over time. This is also our intention because there are different use cases and there will be different kind of profiles in the past, in the future. So to give you an idea, it seems it's working again. So this is how it looks like. And you can see some are in a draft status and some were already created. If you click now on draft, you go directly into our GitHub. So everything is hosted in GitHub that you just saw on mas.owasp.org. So everything is a markdown file. It's just been thrown together on mas.owasp.org. So it's really easy to digest and go through all the content. But for as this is now starting with the weaknesses and we only have now a small set of them, there's of course still a lot of work that needs to be done. And if you click on the weakness on the top right, then you will on the draft, then you can go directly to our issue here in GitHub. And if you would like to contribute or you want to dive into this topic, then it's a great opportunity to get this ticket assigned to you. You can reach out to Carlos or myself. You can work on it. We can give guidance of how this actually should look like, the test cases and everything around that. And you can contribute to our project. Even though for the ones that were already created, like this one here, You can also make changes to it if you just click on them. So if we open, for example, one weakness, you can go here. So this is an existing one. You directly come again to our GitHub repo, and then you can just make a pull request, for example. So if there's a tiny specific change that you think, a typo, or maybe something that we have missed, you can make the change directly here, creates a pull request, we can review, and then eventually it will get merged into our repo. Okay, so the other thing is an overview about the weakness itself. So how does a weakness actually look like? It always follows the same structure for all the weaknesses that we have created. So if I go back to mas.owasp.org, we go to the MASWE. Let's go to the one that I mentioned earlier, the PRNG one. It will always have a short overview, which is explaining what this weakness is about. Then we will have a section about the impact. What kind of risk does this actually have, this specific weakness? Then a mode of introduction. How is this kind of weakness usually introduced in the code, for example, by the developer? What was being used, maybe in this case, an insecure random API. And then we will give an overview in terms of mitigations. Again, on a high level, what can be done to really make this good? And then we have the tests. So for the tests, they also follow one specific format. So if we go now to one test that is tied to a weakness, we have an overview, just again explaining this test now in detail, what this is really all about. Here, non-random sources usage. Then we have the steps that you need to follow in order to verify this test. The observation, meaning how this test, how the output should be evaluated later on. And the observation is then telling you when this test is failing or when it's actually passing. So therefore we have the weakness. The weakness has then tests. And as part of these tests, there are also demos, which Carlos will show you in a minute. So I was explaining already this, and the MASWE is available as a beta at the moment. There's a lot of work, of course, that need to be done for this. But the framework that we have created now, we think is a really good starting point in order to really encapsulate these tests, bridge them together with weaknesses, and get a holistic understanding how weaknesses and how the testing can then also be done as part of the MAS project. And with this, I will hand over to Carlos now for the demos.
Awesome. Thanks, Sven. Hello, everyone. This is Carlos. Let's take a look at the demos. This is personally for me one of the most exciting parts of what we are doing currently, because apart from what the MASWE gives you now, which is a common language to talk about mobile application issues in general. And I say issues intentionally because that might not be only security, but might be also things like privacy, right? So it provides this common language. In the MAS project, we also give you and describe ways to test for those, as we just have seen, but there is more. We give you actual code samples that you can use, that you can download, and you can play with. So these are the demos. When you go to a demo, that you can always navigate from a test to a demo, or you can just go through the menu to the demos right away, you will be here. And maybe Sven, do you mind going to the other screen and just showing this live in the site?
Okay. Sorry.
Just clicking on the demo right away.
Sorry, you are sharing screen now? Okay.
No. I meant if you go to the
Oh, sorry. Okay.
to the website.
Yeah.
Just click on that demo, for instance.
Yep. Gotcha.
Yeah. So we're here, and you see the demos. The first thing that they have is the sample. So you see there is a whole file here, includes the headers, the class, everything. This one is pretty small, but there are others that are bigger. We also include the reverse version of it because when we test these apps, we do it from the perspective of an attacker, and an attacker won't have the original code, right? So they're going to reverse engineer the app, and this is what they will be able to look at. If you know a little bit about mobile security, you will know that in the case of Android, it's pretty easy to decompile depending on obfuscation and other things that might be in place. But if there is not much, you will get a code that is similar to the original one. And iOS is another story and is more complex. But let's take a look at this. We have a sample, and then if you scroll a little bit down, we tell you, hey, look, here are the steps that we defined in the test, but now we are running those steps with actual files, tests, and that sample. So in this case, we are using a specific tool. In this case, is SemGrep, and we wrote a rule. This is how we describe what we are looking for. So you can see here, this is the rule, and we are defining a couple of patterns. So we are searching for things that are actually not random. Sven mentioned before the dates, and you can see here system current time millis. These are typical things that a developer may use thinking that it will end up being random, and it won't. So we are going to detect that using this code. Then if you keep scrolling, we have the actual run script over there. It's a shell script. And then if we go further down, then you will see that we define what the observation is. This is what is the output of our test, and this is the output. And in the end, we are going to evaluate it. So in this case, we have two instances of things that are not random sources. Therefore, this test is failing. So this is this doesn't only stop here. We're gonna go back to the slides because we have created two apps, one for Android and one for iOS, so that we can run all these demos using those apps. So we have them in separate repos. And here you see one for Android and one for iOS. And in the next slide, we see how easy it is to play with these apps and with the demos. You can just go to the website, copy the whole file. There is even a button to copy all the code. Then you go to the app that you have cloned from GitHub, open it in Android Studio in this case, or an Xcode if you are on iOS, and you can just paste it and run it on the simulator, emulator, and there it is. It will, if we have time at the end, I can demo this for you. It's really easy, and it just works because everyone that is developing these demos, it is mandatory to test it with these apps, so you can be sure that all these demos will be working. And this is great because you have this specific sample that contains that very specific issue we are talking about. So the one that Sven mentioned before about random numbers, the one we just saw about non-random sources, whatever the weakness is, we're providing you not only with how to test, but actual samples and examples of that. So next slide, please. And this is how we do it. So we define all those demos, all those files, the Kotlin file for iOS, for Android. If we need the Android manifest to be changed, we also include that. And then we take that, we take the MAS test app, and we put that together. We have pipelines in our repo with GitHub Actions, and we have a way now to generate APKs. So it's not only that you can see the sample code, but you can actually get it and download it, reverse engineer it yourself if you want to, run Frida scripts against it. You can do anything. And we are orchestrating this in our pipelines here. Right now, we can only generate the APK files. In the future, as you see on this slide, this is what we plan to do. We plan to actually do the actual testing, run the scripts for testing, and do all this validation. So it's kind of unit testing our tests for you. So you know everything is working. As you may know, There are several versions of the operating systems, and as things advance, we will need to recheck that everything works, and this will be the mechanism that tells you that everything is working continuously. So next slide, please. In this slide, we see this automation. This is just to show you what we did. We intend to do this also for iOS. For now, we just have it for the APKs. So we have this automation in place that takes the app, takes the sample code, brings that together, and for each demo generates an APK that you can download. Once you have that, next slide, imagine you downloaded one of the APKs. So typically, and this is in the MASTG, because the MASTG tells you everything that is to know about testing mobile apps, right? You will see, oh, you can actually unzip an APK because actually it's a zip file. You just rename the extension to zip, unzip it, and then you can explore it, explore the insights. The MASTG also tells you if you have an APK, you can just open it in Android Studio. Android Studio had a feature for that. So you open it in Android Studio and you end up with a screen like you see here. And you can see it's not the reverse code, but it's like semi-reverse code. It's called Smiley in Android. Again, the MASTG explains all of this. So you can explore all that code. Please go to the next slide. You can also get all the files from our demos. Our demos have scripts and things that you can actually run against that. So if you click play, you will have the application running, and then you will see that this demo also contains a Frida script, and you can then run the Frida script. Frida will attach to the app on runtime and call several functions or hook several functions. So you can see in this case, it will tell you that the app is writing a couple of files to the external storage. And that's not good if the data is sensitive. Next slide, please. Yeah, and here with Android Studio, you will also be able to validate that those files are effectively on the storage because it offers you a device explorer. So you can go to the actual paths where the app wrote the secret to a file, as you hopefully can see on the screen, but if not, you will see it on the slides later. So please, next slide. Yeah, so before we finished, I wanted to let you know about this. So we have a program for MAS advocates, and we would like to thank our biggest advocate, which is currently Now Secure. We are expecting to have more. And this is, you can donate to OWASP, which is extremely helpful for the project, but this is not about donations. This is about putting people to work for the project and helping us bring things forward. So this means there are actual people spending time on the project, opening pull requests, reviewing pull requests, etc. Together with this, we have a group of experts that if you click once more, it's called the MAS Task Force. So we are working with several companies currently to make all this happen. As you can imagine, there is a lot of work going on here. And of course, we have the community, but there is a lot of power coming from companies that are able to donate like people resources, so to say, right? Hours to help us make this happen. And currently, this is an invite-only group, and we only accept experts from companies. So if you are an expert and your company would like to participate here, let us know. Otherwise, you can participate in the project regularly. Just ping Sven or myself, and we will get you onboarded. So this is open for everyone, but for companies, I wanted to let you know that this group exists as well. And yeah, this is us again. Please reach out to us. If you have any questions, reach out to Sven, who's physically there. Today you have the chance. And in our website, you have our contact. You can reach out on Slack and GitHub, LinkedIn, whatever you want. We are there to help you. So thanks a lot, everyone.
Do we still have time for a few questions or? Yeah. Okay. Then if anybody has a question, there's a mic coming.
I have two questions. I'll ask one here and then the other one.
Sure.
What about React Native and Flutter?
Okay.
Is it still the same because they will generate APK and then you guys can do it? I'm going to call it magic.
So the thing is, a good question. I mean, we had 3, 4, 5 years back, I cannot recall, we had an initiative to also cover all these kind of different cross-platform frameworks, React, Flutter, Xamarin, whatever they are. The thing is just that it's already quite hard to keep up with everything that is happening natively, what you can do in Xcode and what you can do in Android Studio. So if you search for it as an abandoned project, that might be 3 years old from us, but we are only focusing really on native code, whatever you can do in Xcode, whatever you can do in Android Studio with Swift and with Kotlin. But at the end of the day, you're exactly right. You will have an APK, for example, for Android. So you obviously can reverse engineer that if it's not heavily obfuscated. And then you can, of course, follow the process that we also have for this. So there are a few tweaks here and there. For example, for intercepting network with Flutter, that's a bit different compared to a native app. So we cover some of these things in terms of the testing perspective. But when it comes to the code, we only focus on Swift for iOS and Kotlin for Android. Okay. Any other questions?
So if I'm not wrong, there's already one mobile top ends vulnerabilities. So
yeah.
Is this one an extension of it or there might be an overlap?
So the thing is, this project, I would say, gives you a holistic view of everything around the mobile space. So there's the standard, all the different control groups and controls around that. We have the testing guide, which, as you can see, is very comprehensive and gives you a good overview. Now we have the MASWE, and I would say that this is a great starting point if you want to dive deeper into the mobile security itself as its holistic overview around it. We are not really related to the OWASP Mobile Top 10 project itself. This is summarizing the different kind of vulnerabilities that other companies might have found. But I would say for us, it's really about giving a holistic view to developers with the standard, for example, to help with threat modeling, also to get a methodology also around that. And also the MASTG to give the perspective to the pen tester to really how mobile apps can be verified. Carlos, did you get the question? Do you want to add anything to that?
I guess not, but that was a good answer. I didn't get the question.
All good.
I just happen to say thank you, but we're out of questions at the time. So
okay.
Thank you so much for that, Carlos and Ben.
Perfect. Thank you so much for joining today.
Thanks, everyone.
And thanks, Carlos, for joining remotely. I know it's already late in Berlin. So
Anytime.
have a good evening. Talk soon. Bye-bye.
Thank you.